In this video, we're going to talk about the nomenclature of cycloalkanes. So as we now know, alkanes can be in a straight chain or they can be cyclic. So if I have a 5-membered cyclic alkane, it looks like this. Since it has 5 carbons in it, this is called cyclopentane. So the only thing that is different is that you now have a cyclo in front, and that indicates that it's a cyclic system. And then again, we still have this ane at the end that tells us it's an alkane, meaning that there are no double bonds, triple bonds, or any other functional groups in the molecule. So that was a very simple cyclic compound. I could have a cyclic compound that had substituents on it. So let's say that we have this guy. So I have a 6-membered ring, so my parent molecule is going to be a cyclohexane because that's the longest. Now in terms of numbering, I can start wherever I want in a ring, so I will definitely start at a substituent. I want to give the substituents the lowest number possible, and since I have 2 groups coming off this carbon here, I'm going to make that carbon 1, then carbon 2, 3, 4, 5, and 6. So these 2 substituents here are both methyls, which means that I'm going to have dimethyl as part of my name. I'm going to alphabetize by the M, not by the D. Remember, we do not alphabetize by di, tri, tetra. And then I also am going to have an isopropyl group. So that isopropyl group comes first alphabetically because I is before M. So in naming this guy, it will be 3-isopropyl, and then a dash, 1, 1, dimethyl, and then I'm going to snake around here because this is all one word here from dimethyl, cyclohexane. So I have 3 substituents, so I need 3 locants, 3 numbers to tell me where those substituents are. It doesn't matter that the methyls are on the same carbon, I need to indicate where they are. If there's a dimethyl, there should be 2 locants out in front of that. So this molecule is 3-isopropyl 1,1-dimethyl cyclohexane. Now it may also happen that you have a pretty long chain, and on that chain is a cyclic substituent. So let's put quite a few on here. So this guy here, this ring, is a 4-membered ring. So this is a cyclobutyl substituent. It's a substituent because it is smaller than my longest chain. So I have 1, 2, 3, 4, 5, 6, 7, 8 carbons, and I got to figure out which side I want to start numbering from. Either way, I run into a number 3 substituent. If I start from the right-hand side, I run into a number 4. So I would have a 3, 4, and that's going to be lower numbers. So I'll start numbering from the right-hand side. So off of my 4 carbon, I have an ethyl, and off of my 6 carbon, I have a methyl. So in this case, my longest chain is not the cyclic compound. So my longest chain, octane, is going to be the parent chain, and the cyclic system coming off of it will be named as a substituent. So in this case, the name of the molecule will be 3-cyclobutyl. Now as a substituent, we say butyl instead of butane. So 3-cyclobutyl, 4-ethyl, and I'm just doing this in alphabetical order, 6-methyl, and again, snaking around, octane. So my parent chain name is octane because that is the longest chain in my molecule. Ane tells me that there are no double bonds, triple bonds, or other functional groups. I have 3 substituents, a cyclobutyl, an ethyl, and a methyl. They happen to go in numerical order, and that's just because of the alphabetical aspect. So C followed by E followed by M, and each one has a locant in front of it. So a cyclic compound can either be the parent if it's the longest chain or the longest number of carbons, or it can be a substituent as if it's not the longest number and it's coming off of a longer chain. Lastly, we might have a compound that is a cyclic compound and it has substituents and directionality or stereochemistry is indicated. So perhaps I have a wedge which indicates that that methyl group is coming up towards me, and maybe then I have a dash over here with an ethyl group. So those are on opposite sides of one another. So the wedge, remember, means it's coming out at you, and the dash, remember, means that it's going back. So in this case, because of the wedge and the dash, I know they're opposite of one another, so this tells me that they are trans to one another, and I need to indicate that in naming. That's going to go at the very beginning of the name. So in terms of numbering here, again, I can start wherever I want on a ring. I'll always start at a substituent. Either way, I'm going to have a 1-3 substitution pattern. Ethyl comes before methyl in the alphabet, so I'll start at ethyl. So I have a 6-membered ring, and this is trans 1 ethyl 3 methyl cyclo, same word. I just don't have a long enough screen here. Cyclohexane. So I have trans 1 ethyl 3 methyl cyclohexane. The 1 and 3 tell me where they are on the ring relative to one another, and the trans tells me that they are on opposite sides of one another. If they were on the same side, then I would use cis. We only use trans or cis when they are two groups, because if there's more than two, we don't know what's trans to what or what's cis to what.